you all for joining today for the Operational Data Science Showcase as we continue Fed Supernova. By way of introductions, my name is Jack Fitzsimmons, and I lead our Deloitte Catalyst team for Deloitte's government and public services industry. In this role, I am responsible for identifying the most pervasive problems facing our government clients, and then leveraging our global Catalyst network of teams from Silicon Valley to Austin to Tel Aviv to identify leading startups that we can work with to accelerate the deployment of solutions to these problems. For many years, the government was a place that startups were unlikely to engage. Acquisition regulations were confusing and outdated, and the sales cycle meant that startups might not be able to afford even working with the government. New acquisition methods like OTAs and SIBRs offer the opportunity to, I think, repair this bridge between government and the startup ecosystem. And this will be especially crucial when looking at the mission and operational challenges across the defense sector. Now, turning to this Operational Data Science Showcase, I am thrilled to have with me 5 startups with capabilities spanning AI, ML, advanced analytics, and robotics. And I want to emphasize Frank Strickland's words at the beginning of this Operational Data Science track. He said that data science is a capability, not a person. I would add to that that data science is also not any one technology solution or startup. And during this showcase, I would really encourage you to think about how each of these startups could solve parts of the problems your organizations face as part of a holistic, multidisciplinary solution. So a bit on run of show for this. Each of the 5 startups will pitch for about 6 minutes. And then at the end of the session, we will have some time for audience questions. So please do enter them in the chats throughout the showcase. And with that, I am pleased to introduce our first startup, Amandra. And we have with us Denis Ignatovich, the co-founder of Amandra. And Amandra's groundbreaking AI helps ensure the algorithms we rely on are safe, explainable, and fair. Denis, over to you.
That's great. Thank you very much, everybody. Can you see my slides? Is that just okay? Beautiful. So we're Amandra, and we specialize in something called automated reasoning. And automated reasoning is a type of AI that deals with analysis of data and algorithms. And there are many possible use cases for products, which is also called Amandra. But I'll just go through kind of 2 very high-level ideas. So first is something called rule synthesis. And rule synthesis is a type of machine learning that is just becoming widespread. And the reason for that is historically it's been very, very difficult to do. So if you go to top conferences in machine learning right now, you'll hear that phrase. Rule synthesis refers to being able to extract logical patterns from structured sequential data. So one example of this is if you let's say if you take 2 chess players and they play a bunch of chess games, and then you record the moves, and you give that information to Amandra, Amandra will be able to automatically generate the logical rules of chess effectively. And that's what this refers to. Other examples of where this might be used is around making sure that, let's say, robotic process automation is conducted correctly, etc. There are many different examples of this in international markets, and we'll get to that in a second. So that's the first part of our product. The second part is once you have these rules that have been created, what Amandra can do is it can actually explain to them how, let's say, the system or environment can evolve into the future. So here I'm using chess as an example, obviously, but so in this context, what we can do is once you have synthesized, once you have extracted these logical rules that explain the game of chess, what Amandra can do is, once you combine that with a specific chess configuration, Amandra can tell you how the chessboard can evolve into the future. Now, chess is an easy example because it's difficult to do it for humans, but with a computer program, it's quite easy to do, to think about all N steps ahead. What Amandra specializes in is, given complex environments that can be in infinitely many possible states, Amandra can actually compress those state spaces and describe to you how these environments can evolve. So now this application, this is around that battlefield modeling, where you have to think about how the battlefield may evolve and step ahead, and really be able to analyze infinitely many possible things that can happen and compress that information to something that an operator can understand and make decisions around. So historically, our work is in the financial markets. So our biggest public client is Goldman Sachs. We have a big exchange that is about to make a big announcement of them using our platform. We just signed a major partnership with a company called Activity, and they're one of the biggest distributors in the world of finance. When it comes to the U.S. Department of Defense, we've gotten a few signals over the past year with F-Works and most recently with the U.S. Navy. The U.S. Navy, we've adapted Monty to analysis of neural network algorithms for collision avoidance systems that are deployed within the drones. And we're working with a couple other opportunities. So we're historically been around in finance, but we're now getting up to speed with the Department of Defense. And most recently, we were part of the Decode Spring 2020 AI cohort, and with their help, really kind of elevating our game in this time. So just to give you a bit more technical details on how Monte works, as I mentioned before, there are two sides to it. One is rule synthesis, we would like to call it extracting algorithms from data. And the other side, the tool side of that, is we can extract data from algorithms. And in this, as you can see, they're kind of duals of each other. And it's important that we're going to explain how this system works. You know, the high level, what a Monte does is it translates computer code into mathematical logic. And once this translation happens, and all this happens under the hood, there are many different cutting-edge techniques that we apply to solve very advanced problems. Again, starting from analysis of financial trading algorithms to analysis of neural networks, things of that nature. One key feature that Armando has that we're using all over the place in production right now is sensor reasoning composition. This is what I mentioned before. Imagine you have a model of an environment or a system, so whether it's, let's say, a battlefield or a complex autopilot system, effectively something that can be modeled using computer code and it can be inferred in many possible states. What a model can do is can analyze all these inferred in many possible configurations and describe them to you through a finite number of symbolic regions. And this is something that we are using day-to-day in finance to test trading systems. This is now we're applying for analysis of neural networks, and there are many different applications of this. And this is very much inspired by the PhD thesis of my co-founder, whose background is in mathematical analysis of autopilot systems, where obviously you have to consider infinitely many possibilities. When it comes to defense markets, as I mentioned before, there's quite a big play for AI for strategic and tactical decision making. This is something that you have probably seen, which is very similar to what U.S. Army soldier goes through when they're analyzing intelligence on the battlefield. Again, we see a lot of parallels between what people do today manually and what a monitor can do automatically and much more rigorously and faster. I think we're running out of time, but to summarize, there are many different applications of this, and we'd love to speak to you, again, from understanding how complex environments can evolve to testing systems to analysis of machine learning algorithms. And we have a great team, and would love to speak to you if you have any questions.
Thank you, Dennis. Appreciate it. And reminder, everyone, we'll have plenty of time for questions at the end, so please do put them into the chat. So next up, we have StreamSets, and we have with us Cindy Baptiste and Mike Carley from StreamSets. StreamSets provides the industry's only data ops platform that enables companies to build, execute, operate, and protect the data flows that drive pervasive analytics. It enables enterprises to manage their data movement as a continuous ingestion practice. So Cindy and Mike, over to you.
Hey guys, and you can hear me okay, right?
We can hear you, thanks.
All right, great, cool. So yeah, I just want to talk to you about stream sets, kind of what we do, how we're helpful, and kind of tell you a little bit of a story about how we've been implemented in the past. So stream sets, to give you an idea of how we're implemented, just one customer success that we've had is stream sets is used to run the largest audit in human history. StreamSets runs the data pipelines that are contained within the StreamSets software are used to run the $2.8 trillion audit of the Department of Defense. Every single pipeline from every single source system to the data lake, the data that the auditors have on their clipboards when they show up to the warehouses to count the stuff on the shelves, that's all ferried through the StreamSets platform. To give you an idea about StreamSets as a company, we have about 150 customers. We have about 40% of the global S&P 500 using either the StreamSets platform or our open source products. And we have a really large history of innovation. If you're familiar with Scoop and Flume, the director of engineering that ran that team is actually our chief technology officer. Our CEO was the chief product officer at Informatica, and we have a large history of other leaders inside the company from Elastic and SAP. And we've won a series of very esteemed awards that we're very proud of as well. But to give you an idea of kind of how we implement the largest audit in human history, this is the platform in a nutshell. We have a control layer, and then we have purpose-built data integration engines. Now, Data Collector is our open source tool, and some of you guys may even be familiar with it. Data Collector is really designed for streaming use cases, some batch, some small sorts of transformations. There's a lot of really neat stuff that you can do. You might be familiar with NiFi. You might have worked with it back in the early 2000s too, before it was open source, and this is a different take on a data movement architecture. NiFi is focused on large files, moving them through a cluster. StreamSets is an entirely in-memory architecture that can be deployed on Kubernetes. And because we've operationalized your data movement, you can actually tie the scalable ingestion to the horizontal auto-scaling pod feature within Kubernetes. So that way you can actually tie your ingestion to an SLA. Transformer is our heavy-duty ETL product that uses Spark under the on the back end. So the nice thing is if you want to use EMR, you have a homegrown Spark cluster, maybe use SQL Server big data clusters if you want to. All of that is capable to leverage Transformer to deploy those Spark apps on those clusters. Now, the orchestration layer orchestrates all of those data pipelines across an example architecture that kind of looks like this. So, you may have a series of data stores in Salesforce or Kafka or databases. They need to ingest, maybe you need to do slowly changing dimensions or change data capture. That's where something like Data Collector would come into play. You build in your trickle feeds, land them into your raw zone, and then you're going to use Transformer for heavy duty batch workloads. So maybe you want to do a billion table join with another billion table, and you want to do some ML or some natural language processing along the way. We have pre-made processors, so that way you don't have to go back and get your PhD to learn Spark and distributed systems. So again, stuff that would require a lot of learning, like let's say you want to do type 2 slowly changing dimensions in Spark, that's all pre-made for you. That's all available out of the box. And then what you can do is you can land those into your consumer system. So it's the idea that real estate of the data pipeline itself, the transportation layer, so to speak, of that data movement is actually really valuable. And I have a small demo that I'll show you where we'll do in-stream machine learning on predicting cancer records. Now, this is a quote from the audit of the comptroller that I was telling you about earlier, where people kind of don't know what a data ops engineer is, or they aren't really familiar with what data engineering is. And it's one of those things you don't realize it until you're actually in it. And so StreamSets actually enables you to do that. And that's a wonderful quote that I think really describes how useful the StreamSets platform is. So to give you an idea of some of the data problems that we solved inside the comptroller's office, you can imagine that it's a change nightmare where data sources are constantly drifting. If you have somewhere on the order of about 3,000 source systems that you need to manage, traditional tools would simply break because they're too brittle, because they can't handle that type of drift. So that is one of the areas where StreamSets shines, is that when we talk about things that only StreamSets can do, it's really the ability to handle data drift. So because we actually are able to help prove out this audit that's never been done before, the DoD actually has a unique capability now where they're actually tying acquisitions data, financial data, manpower data to battle space awareness, command and control systems, and actual mission outcomes. So that way you can tie a dollar spent on the back end on the healthcare and the wellness of individual soldiers, sailors, and airmen to the actual outcomes on the battlefield themselves. And that's a capability the DoD never had before, and they leveraged StreamSets to actually take advantage of some IT real estate, so to speak, that's gone underutilized in the past. And that's data ops in a nutshell. So to give you an idea, we have a bunch of different use cases. This is a couple of screenshots of what it looks like. And I'll just go ahead and jump into the demo real quick. So I'll go over here. I'll go into my cancer classification demo. So what you can see here is just a quick little pipeline that I put together. I have breast cancer data. It's designed to simulate the pipeline being deployed on a mammogram machine or really any IoT device. And what I'm going to do here is I'm actually going to leverage preview mode and rather fully run the pipeline. And you can see here I have some information. And what I'm using is this pre-made TensorFlow model. And I'm actually going to ask the TensorFlow model on a record-by-record basis to actually classify the data. So you'll see here that I'll either have a 0 or a 1 associated with that particular scan of the cancer record itself. And so what you'll see is based on what's going on inside the cancer record, I'm actually going to stream that to the appropriate topic. So whether it's benign or malignant, you'll be able to see that as part of your in-stream analysis. So what we'll hopefully do with the DoD going forward is you'll see a real-time audit. It won't be a yearly thing. It'll be something happening in real time. So that's how StreamSets is deployed. That's what data ops in motion looks like inside the Department of Defense. And I look forward to your questions. Thank you very much for your time.
Awesome. Thank you, Mike. And I think it's something that we can all hope for, that the DoD audit is as easy as you envision there. Next up, so we have Veriset, and we're pleased to welcome Parker Entz, the CEO, and Venu Ganesh, the CTO of Veriset. Veriset is a data as a service company that fuels innovation by providing high quality movement data to problem solvers and data scientists and startups, enterprises, and public service. Veriset, over to you.
Great. Yeah, great to be here. Thank you so much. My name is Parker. I'm the CEO of Veriset, and Venu's here as well. Our CTO, he'll be ready for questions afterward. So just to introduce Veriset, show you how we're a little different than what you've seen today so far. This is a recreation of Paris. And it's not a map, but it's actually the aggregation of billions and billions of GPS location signals that we've plotted on a map. And this is a representation of the kinds of location data that we have available at Veriset. So every day, leaders like yourselves are trying to answer important questions using pattern of life insights. And one source of these insights is location data that comes from smartphones. And with smartphones becoming almost universally adopted across the globe, there's an entire breadcrumb trail or digital exhaust available of how people are moving around that inform a lot of different important and interesting questions. For example, understanding when a smartphone device has visited 2 areas of interest, or identifying suspicious points of interest based on the movement of smartphone devices around that point of interest. As one example, we had a federal law enforcement agency that was able to use the data on 2 sides of a border and identify suspicious activity devices popping up in both of those areas, and we're able to actually identify drug trafficking sites based on the movement of those smartphones. Other use cases include analyzing population movement over time, monitoring protests or other surges of populations or gatherings, and in mapping, finding new roads and places that were not known before. So the only problem with using this kind of location data that's available from smartphones is it is hard, expensive, and messy to acquire. It's scattered across thousands of mobile applications. It costs quite a bit to gather this data. We spend millions and millions of dollars a year acquiring this data set. And because it's such large data, it's billions and billions of rows per day, it's very expensive just on the engineering effort to actually transform and validate and clean the data so that it's ready to go for data scientists. So that's where Veriset comes in. So we're the leading provider of type of data. We're just a data company, so everything that we do is about sourcing this data and delivering it to problem solvers. Our leadership team is former Palantir, Google, Stanford, and a lot of data industry folks. And we actually spun out of another geospatial company called SafeGraph last year. So we are the leading provider to many brands, many of the Fortune 10. A lot of academic researchers rely upon our data, as well as a number of proof of concepts within federal government. So we make it very easy. We go out and find all of the data. We validate and clean it and remove data that has low signal or a lot of errors. And then we deliver that data daily, billions of rows a day, and it's conveniently delivered to an Amazon S3 bucket, ready for analysis, either by your team or by your partner's team. We have two primary products of interest to this group. The first is our USA movement panel. We see over 35 million daily devices and over 167 monthly devices with precise location on those. And then we also have global data. So our global data is everywhere in the world other than the EU, and approaches 400 million monthly active users. The data set is typically a unique and anonymized identifier that identifies a single device, and then a latitude and longitude reading, as well as some other metadata about that latitude and longitude. Security and privacy is paramount, so we don't provide personally identifiable information. Everything is de-identified. This data is commercially available and is compliant with other data privacy laws. I'm happy to answer other privacy questions. Just wanted to give you a few examples of some use cases. So this was a large prime that was able to identify unknown roads in Ukraine. And you can see the green lines in the image were known roads. The yellow points are Veriset movement data, and then the red lines are new roads derived from Veriset data. Second example, this is the example I mentioned before, identifying suspicious points of interest by drawing geofences around two areas of interest and analyzing what devices popped up in both. And then we've also been doing quite a bit recently with COVID-19 response. So we've been working with nonprofits, cities, other government agencies to monitor social distancing, build predictive models for where the disease might spread, and also predict economic recovery. And this is an article in the New York Times featuring our data, analyzing which kinds of points of interest were more or less dangerous to visit as far as social distancing efforts. Planning, so infrastructure and transportation. This was a customer to figure out where to charge station based on traffic analysis derived from our data. So I will just make one more comment, and that is if you want to work with the Veriset data, again, we're just a data company. Our product is essentially lots and rows of data. And so you'll either need data science resources in-house, or you'll need partners. And we've actually have one proof of concept with Deloitte. They were building their own COVID-19 panel. And so you can see some of that there. They were basically trying to identify underserved areas in the United States where people were having to travel too far into a site. So I'll leave it there, and happy to answer questions later. Thanks.
Awesome. Thank you so much, Parker. So next up, we have Rise. And with us, we have Colby Harvey, the CEO and founder of Rise. And Rise is reimagining aircraft inspections and ensuring safety is at the forefront of every flight. Colby, over to you.
Hi, sure. Thank you for having me on. I'm just getting everything over. I'm sorry, Epic office hours kind of kicked me a little bit. So thank you everyone for being here. Again, my name is Colby Harvey. I'm the CEO and founder of Rise. We focus primarily in the aviation industry. So I'm going to give you a little bit of an overview about what we do and who we work with. So to get started, I want to give everyone a little bit of a background as to why the Rise came to existence. So just throughout my years of studying aviation, being in the aviation industry, working at several maintenance, repair, and overhaul facilities. These are facilities that actually service the aircraft for airlines. I know there's a big problem that was pretty glaring to me, but didn't seem to be glaring for many other people. The first thing that I noticed were the length of the inspection times and how dangerous they are to both the inspector and the aircraft. Next, I noticed the inconsistency in how aircraft or damages are cataloged, and which with the inconsistency in their cataloging, it makes it very difficult to create historical models and then moving forward to predictive models with enough data to only go back maybe since the drone really started, or if we're able to port over any of the information. And last but not least was the amount of revenue, which is in the billions, lost annually for commercial aviation on these aircraft inspections. They take anywhere between 6 to 10 hours to complete, depending on the inspection type and the aircraft size. Also, one of the biggest challenges is how they are inspected right now. So generally, they're inspected by people that are climbing on the sides of the aircraft. They're being tied to the ceiling. They are having scaffolding or skyjacks. And you won't hear this much from the aviation industry because it's as a focus of safety. But inspectors sometimes make mistakes where when they're looking for damage they cause more by running the skyjack into it. So to give you guys a backup of who we are, so Rise is a advanced artificial intelligence robotics company with a pure focus in the aviation space, as this seemed to be the most glaring space and also one that's very close to my heart personally. And we came up and we developed this technology to ensure and to commit to ensuring more safer inspections and much more cost-efficient ones as well. So the solution was pretty simple. We created an autonomous UAV or UAS system to perform a 100% autonomous solution. This solution is done by using segmentations of different maps that we use because we utilize a GPS-denied technology platform that's able to navigate with effectively in restrictive spaces. So being inside of a hangar, as that's where we operate right now. That information that's collected from the drone is then retained and cleaned and through our artificial intelligence pipeline and analyzed with our computer vision engine and sent back to the end user to address any issues that it may have detected. And then we use the stored data for predictive maintenance. A large part of the industry is looking forward to predictive maintenance to bring in aircraft before there's an issue to address the issues that will arise as opposed to playing catch up. So one of the biggest things that sets us apart from our competitors in this specific space is the thing that I mentioned before, which is the GPS denied navigation. Now it's a very complex and complicated system that we have running on board the drone. It uses a multi-layered approach of navigating in a three-dimensional space by using the three-dimensional LiDAR that we utilize on the platform itself to create maps and compare it to maps that have already been created in the environment that it works in. We also have a analysis software that uses that's actually pretty unique in itself and by using federated learning. So every drone that's in the field is consistently updated with the most accurate and most up-to-date computer vision models when it's identifying damages. So the data set is then used to reduce any miscategorizations or misdiagnoses in the aircraft damage. And the platform is ultimately tailorable and specifically tailored for the aviation space. So it's not a one-size-fits-all. It's uniquely purposed. So we've done several pilots with some leading people in industry, one of which being AAR, which is a very large maintenance, repair, and overhaul facility that is located globally. One of the largest customers to date that we've worked with, that we're currently working in a testing and ultimately a leasing agreement, is Boeing. So they want to utilize the technology and actually press forward and bring this technology to market into the forefront of the industry. So just give everyone a little bit of a use cases as to why this software and this technology is necessary for the industry. is lightning strikes. For example, like I said, right here, you see a pilot reports a lightning strike happened during normal flight servicing. These lightning strikes can take anywhere between 6 to 10 hours. This is dependent upon the size of the aircraft. With our analytics platform and the UAS itself, we're able to reduce that inspection time by 90%, being able to identify those damages in about an hour or less, and report that information back to either say it needs to be addressed based on historical models that we've used or we've ingested into our platform. And again, if it needs to be addressed, or if it's something that is fine and the plane can go back into service, which has a significant cost reduction for the air carrier. Next, it's kind of along the same lines, is the hail damage. So that happens much more often than you think, and requires a lot of resources and a lot of work to actually finish it, to identify these damages. With that being said, the software is able to determine the length and width, location, and relative location of the damage on the aircraft using waypoints. And lastly, are just the general typical inspections that take between 400 to 600 hours. That happen after every 400 to 600 hours. Again, so our drone is able to reduce this by about an hour or less, depending on the aircraft type. So with that said, that's about all I have for everyone. If anyone has any questions, please feel free to throw them up. If not, then I will turn them back over.
Thank you, Colby. Appreciate it. And
thank you.
We have Sisu with us. So Grant Shirk is the VP of Marketing at Sisu. Sisu is the fastest and most comprehensive diagnostic platform for structured data. Its diagnostic analytics platform combines ML and powerful statistical analysis to help anyone get answers to their toughest business questions. With that, Grant, please take us home.
Hi, Jack. Thank you very much. Let's see. Let's get the screen up here. Fantastic. Nice to meet all of you. My name is Grant Shirk, and I am the head of marketing at Sisu. What we're going to talk about today is proactive analytics and helping to put a lot of this complex data that you are capturing and structuring to better, more effective use across the organizations. This is a challenge that we hear constantly from our customers. We've just spent the last 30 minutes hearing from a ton of services and tools that help you capture, integrate, and structure data more effectively. Unfortunately, it creates this paradox where there's so much data and so many metrics and KPIs that we're looking at, it's impossible for even the best team of analysts to monitor them all. It would take days to go through all of this information and actually find what's relevant, what's interesting, and what's actionable in time for it to matter. And this is at the core of the analyst's dilemma. It's kind of the best of times and the worst of times. And the issues that we see is that we can't get answers fast enough from all of the rich data that we're collecting. As a result, because we can't cover it all, we're not confident enough that the answers we're getting are correct. And you can't send someone out into the field or drive a critical decision based on incomplete data. And as a result, people and organizations are still making decisions that are unclear and based on gut feel as opposed to data. And this is a familiar scenario to most people, depending on what your use case is. You know, we have lots of visualization tools. We've seen great opportunities to drive these reports and data science tools. But the analysts and your consumers of the data are left squinting at the information. And as soon as you show a report, you drive these questions. Whether you're looking at employment and economic information, why are we seeing unemployment spikes in Chicago? If I'm trying to drive the maintenance and the management of my fleet, where am I seeing unexpected breakage and how do I get ahead of it? This is a scenario that we helped Tesla with as they were looking with battery drain across their fleet of hundreds of thousands of vehicles. And even when you think about people readiness and putting folks into the field, understanding the subtle differences between why we are seeing higher and lower readiness rates between different teams and different cohorts. This is why Sisu was created. This is our founder, Peter Bayless. He's a computer science professor at Stanford University, and his entire lab, which spawned Databricks, Google, and others, is really trying to understand how we can work with complex data, answer tough explanatory questions orders of magnitude faster than conventional analytics tools, and continuously evaluate that information and provide proactive updates and insight as to what is happening without having to go and pull that data manually from the tools. It's this fast, comprehensive, and proactive approach that has driven a lot of our growth and also created some really interesting use cases. And I'm going to walk through a couple of these and some different ways to think about how to accelerate the pace of analysis and finding facts in your data. Certainly the first thing that we can provide as you're collecting these billion row data sets that are hundreds of columns wide is helping your teams automate the rote work of analysis. If you look at the kinds of data sets that we see with our large customers, there are hundreds of millions, if not billions, of combinations. And Sisu has the ability to test all of these hypotheses in seconds. The analysis that we have here that's looking at 400,000 rows of data and 400 million combinations takes about 4 seconds in our platform, meaning you get fast facts about what matters. We're also excellent at finding and surfacing the highest impact populations. Not just finding spurious or interesting correlations in the data, but really trying to understand which groups, which behaviors, and which combinations of features are actually driving the highest impact to the metrics that you care about. So whether you're looking at something fun like media streaming or something critical like which cohorts are performing better in the field, you need this information quickly. You need to prioritize the analyst's attention on what matters. And then ultimately really understanding the differences between these populations. Looking at that lightning fast category and context analysis to really look at text, categorical data, and continuous data to understand and drive decisions over time. The reason we're able to do this is building on the research at Stanford. There's really 3 components of the platform that can help your organizations make more efficient use of this cloud scale data. One is the cloud native architecture that's designed for this highly parallel processing. The second are our efficient search algorithms that allow us to move through and prioritize the factors in the data that matter the most faster than any other platform. And we know that time matters in these kinds of analyses. And ultimately getting better over time, using the statistical signals and user input from the tool to improve the overall ranking and relevance of the results from the platform. It's this technical differentiation as well as our early investment in security, privacy, and compliance that's helped us drive some significant market momentum with large, complex, and privacy-conscious organizations like Samsung. They used us to help drive the launch of a $1 billion product earlier last year and really understand across tens of millions of customers and hundreds of device profiles what was driving behavior change across this population so they could adjust what assets they put into the fields to change customer behavior. And then ultimately at the hedge fund who's dealing with tens of millions of transactions a day, cutting analysis time down from weeks to just a few hours. All right, thank you very much. Looking forward to the questions, Jack. I think we're headed over there next.
Yes, awesome. Thank you, Grant. And so everyone, just as a reminder, if you have any questions, please do put those in the chat. But what we're going to do is start with a question from the audience. And Parker, I'm going to direct this to you first. So what are the most important current limitations to operationalizing AI that users should be aware of?
Yeah, so I mean, non-comprehensive answer, but just kind of 2 things to think about. So one is there are a lot of smart people figuring out amazing algorithms, and it's still going to be garbage in, garbage out. So like you have to structure the data and you have to make sure that it's acceptably accurate. So it'd be kind of the first thing. And the second thing is like, yeah, like if you're kind of new to the idea of artificial intelligence or machine learning, it can sound kind of intimidating, but in the day, it's like very complicated statistical predictions. And so these things have to be trained. And so, yeah, it's like important to have both the right data as well as the right algorithms and the entire support system around that.
Awesome, appreciate it. And Mike, as StreamSets was working with the DoD on the audit, what were some of the challenges that you found to really operationalizing the product that you had in the DoD environment?
Yeah, I mean, it's one we still face, to be honest. I always tell people, think about your reports and dashboards the same way you would think about cars. it's a highly engineered product that you're ultimately buying. And so the application of lean manufacturing principles or Kaizen principles, if you kind of follow Toyota's model of making cars since they kind of led the way, really changes your approach to operationalizing machine learning. Machine learning is a highly engineered product, and you shouldn't focus so much on the outcomes as you should focus on the cycle time to develop that, because it's ultimately the number of iterations and drafts that ultimately make a machine learning algorithm very valuable.
Completely agree. I think it's a common refrain that we need to walk before we run. And I think the more government agencies can do, proofs of concept, pilots with these solutions, it'll help them get to scale much faster and more successfully. So Colby, I'm going to go over to you with this next one. So, the defense side of the government has really done a lot to improve the contracting environment. But what is one thing that defense agencies could still do to make it easier for startups like yourselves to work with them? Oh, did we lose Colby? Okay, Dennis, that question is going over to you then.
Sure. We've had a great experience with something called Decode, which is this DC-based accelerator, and there is just so much information that we've learned there. Everything from the fact that we should get a lawyer when we're filling out all of these cryptic IP clauses, etc. That's just off the top of my head. Really navigating all of the different contract types, the different opportunities, like NASA suit. Things of that nature. My recommendation would be is not to create, like a FAQ website and say, here's what you do, because it's such a complex thing. But my recommendation would be to partner with somebody like Decode, because it's a really complex issue, and there are many stories where people don't, basically make sure everything is legit, and then it ends up in tears. Years down the road.
Totally agree. And I love the plug for Decode. And Megan was on the previous panel. Decode's been a great partner for Deloitte for a number of years, and I know has helped a number of commercially successful startups enter the government space and really navigate the FAR and all the specific lingo that exists in the government. So shout out to Decode for continuing to facilitate that process. So Grant, I'm going to kick the last question over to you. I think it's important to consider the investor angle in here. On some of our panels, there have been venture capital partners. Do your investors encourage you to work with government clients, or do they, shy away from it because of how long it can take to see return on investment?
Yeah, I think if anything, they encourage us to get involved in government conversations as early as possible, simply because I think a lot of people underestimate the complexity of the process. I know for us, all of our investors have been both very proactive about making introductions, as well as providing some of that guidance and lessons learned from prior cycles that they've been through. And it's helped not only educate our team and early founders, but also help accelerate some of these conversations. Agreed. Well, with that, I think we're right at the time. So I want to thank once again Amandra, StreamSets, Paraset, Rise, and Sisu for joining us for this operational data science startup showcase. I believe we will be sending out all of the contact information for all of our showcasing startups. If anyone has specific questions, I know there was a specific question for StreamSets about health data. So please do reach out to all these startups and understand with them how they can help you solve your organization's biggest mission and operational problems.